All right, so we're here today to talk a little bit about Zephyr on Nordic's Nrf52 family. I've got some slides to share here. And let's see, I want to be able to see the video from folks here. Okay, so are you able to see my screen? All right, so basically today, quick agenda is just we're going to talk a little bit about the history of Zephyr and just kind of the layout and how it came to be and what setting up some of the tools kind of looks like on paper, and then we're going to do it and program a couple of test applications and play around with it a little bit today. Real quick, this is me, I'm Joe. Call myself a family man, dad of 3 girls, and an amazing wife who puts up with all this crazy embedded stuff that I do. Been doing embedded for about 20 years, multiple agile transformations. That's near and dear to my heart, and just a strong passion for improving the state of the art. So I like to push the envelope. That's what Dojo 5 is all about. We're a product and services company in St. Paul. We are embedded software experts out to modernize the firmware life cycle. So Dojo is kind of about this environment for immersive learning, which this web talk is kind of demonstrating. And then 5 is kind of a foundation of family. So just we have a family atmosphere inside and with our clients. And that's the type of culture we try to build. Enough of that awesome stuff. Let's jump into it. So when Nordic first came out with the Nrf5, they delivered something called the Nrf5 Sdk, and that has gone through iterations all the way from like version 1 to all the way up to version 16. So it has lived for a number of years, I think 4 or 5 years. It has no RTOS built in, though you can add free RTOS to it if you want. And it uses something called soft device, if you're not familiar with that allows for BLE support, and you don't have to think a lot about it. It has some callbacks that allow you to implement a pretty rock solid BLE implementation without doing a whole lot. So it has great examples, lots of driver support. But what I've been hearing from Nordic is that they realized a year or 2 ago that they wanted to put a multi-core device in their family, and there was no clear path to multi-core devices for that thing. And so I think they recognized they could go off on another really big R&D effort to try to make the Nrf5 SDK match that, or they could go to try to find something that was out there. So enter Zephyr. So it began as I don't even know how to say that company, but Ionic Virtuoso. This is like an RTOS that existed in the early 2000s. They had a little bit of traction, but they weren't really seeing a lot of opportunity, and eventually Wind River bought them, looking to kind of expand their line of RTOSs. Of course, they had Wind River Linux. They've also got VxWorks. So Rocket is what they called it and rebranded it to, and that kind of served this kind of low-end micro. And then Wind River didn't really find a great way to commercialize it, and so they got bought by Intel. Intel kind of made it work with x86, and they're like, hey, let's just open source this and let's make this a thing that the Linux Foundation can just curate moving forward. And so then Zephyr was born. Zephyr still has ties to the Wind River and Intel guys, but is also an independent project. So built with Linux principles, I'll say a lot of the API calls look a lot like you're programming for Linux. And it's open source, 40,000 commits at this point, so it's fairly active. Yeah, it's really some of the folks who are involved with the Zephyr, they describe it as like basically serving the under 2 meg space in embedded. So you really about the lowest you can get like embedded Linux these days is about 2 megabytes for an image. If you want to go lower than that, you're kind of at, tough out of luck. So that's where Zephyr kind of fills. And all of the Nrf52 devices that we're talking about today, they're all 1 mega flash or less. So Zephyr is kind of filling a space there. Just kind of an idea of how the Zephyr releases go. They have an LTS program, and so if you have you want a stable version of their product that you can depend on for longevity, they do LTS releases every 2 years. October 2019 was the first one that they did. And then they started their 2.0 release. That's when they added 32-bit and 64-bit support, or really added 64-bit support. 2.10 was kind of a normalize APIs and add some additional platforms. And then 2.20, they added CanOpen and LoRa, among some other things. So, and you can see that their cadence is pretty fast. It's about a 3 or 4 month cadence. So they're trying to move pretty quickly. So diving into some of the tools that we're going to be using here. West is kind of the big one. It's a multi-repo tool. If you've ever used repo, or I don't know, I'm blanking on some of the other ones, but those, you know, it basically, it's in lieu of using like straight up Git submodules. It helps us to just kind of pull in different pieces of Zephyr. It's kind of broken, Zephyr is broken down into a lot of different modular pieces to help support different CPU architectures and stuff. So West kind of coordinates all that. Mainly we'll be using West init to initialize the repo, West update to kind of update all the sub repos, and then West build is what allows us to actually do builds. And then just a note on environments. So Sager Studio is available. It has been available for the SDK, Nrf5 SDK, is also available for the Zephyr-based projects, but you do have to use a special version of it, and you can't download it straight from the ARM or from the Sager website. You have to go through Nordic's kind of getting started NRF Connect desktop tool to even get the link to download it. So just a kind of a cautionary tale there of how to, you do need to have the Nordic edition for any of their examples to make sense of why don't I have that menu? So yeah, and so jumping into it, first thing, the easiest way to install, there's a lot of dependencies for this tool chain. And so easiest way to get started is use NRF Connect Desktop, which is available on the Nordic site. It basically has a wizard that walks you through how to do it. I'll just, let's see if I stop presenting here real quick, and then just jump to what this looks like here. So this is NRF Connect running the NRF Connect SDK. So when you get this, when you first pull up NRF Connect, you'll get this list, and it's a bunch of different apps that you can decide to or not run. It's the getting started assistant that you're looking for. That's basically the guide to set up the NRF Connect SDK. It'll do the appropriate thing when whether you're running on Mac OS, Linux, or Windows. All three are supported. So when you open that, you get this lovely wizard. It talks to you a little bit, gives you a little bit of an overview. But then the nice thing is it kind of walks you through everything that you need to install. You'll need CMake, Ninja, gperf, Ccache, all of these guys. Python 3 also required. Can't be running Python 2. And then at the bottom here, we get to the GNU ARM embedded toolchain. This is just GCC for ARM. ARM distributes that from their website. So but they give you a link here to make it really easy to go grab that. I've already done all of those things, but it's a pretty quick, nice little wizard to just kind of like hit install, hit verify, hit install, hit verify, and then it just kind of walks through it for you. So pretty quick and easy. This part is where they start going some places where I like to deviate a little bit. And in this part is where they install the West tool. And that's where I like to do some stuff inside of Python virtual environments so that I'm not polluting West all over the place. Just be aware that you do need to install West globally if you want to use Sager. But in our case, I'm going to do a lot of command line builds first, and then I'm going to kind of show Sager at the end. And so I've got West installed both globally as well as in a virtual environment. And then we kind of get into the initialization of the repo. And so this is where the fun begins. Any questions so far? All right, cool. Let's jump to getting things going. now let's back to the slides real quick. So installing GCC. I just want one note. Make sure you get the right version there. The version is important. It can affect your ability to compile this correctly. So just make sure you get the right one. All right, so from an installation standpoint, this is typically what I do. There's a couple extra notes down here that basically are additional settings that you want to set to point it to your the version of the GCC compiler if it's not on the path. So I'm going to run those in my terminal window here just to kind of set up the path. There's a toolchain variant, which we want to set to GNU ARM EMB, and then there's a second one called GNU ARM EMB toolchain path. Now, if you're more familiar with Windows, these are going to be environment variables that you want to set. And so then what we could do is basically set up our environment. As I mentioned, I'm going to create a virtual environment. This just allows me to kind of segment off all of the Python requirements that are going to get pulled in, because not only are they the ones that I'm explicitly installing, but there's a number that that Zephyr wants to install that we kind of want to keep separate from our main computer here, or I like to. And then so once we've created the virtual environment, we'll activate it. And now you can see we've got this .vm here, which is just saying that, hey, I'm inside a virtual environment now. Now we can pip install West. The -U, just if I've already got West installed, it would upgrade it. And so now we've got West installed. This little warning here is just saying pip's out of date, and that's okay. And now we go grab Zephyr. And importantly, we're grabbing Nordic's kind of overlay on top of Zephyr, and we're also grabbing a tagged version of Nordic's overlay. And I found that that's fairly important, just to make sure that you're getting a combination of things that's going to build. And then Nordic is constantly pushing stuff upstream to Nordic or to the Zephyr project, but they are it takes some time sometimes to accept those PRs, and so Nordic's Nordic's area is really like has additional board support oftentimes, or has additional like processor support or dev kit support that is not in mainline quite yet, so that you can kind of get the latest greatest from Nordic, and they're not beholden to those guys. So, all right, so here we will initialize, do West init, and so this basically grabs the top level repo here from Nordic Playground. At this point, we have some code here, and I'll just switch over to VS Code, which is going to be my editor of choice here for the moment. So what we've got here, so here's my virtual environment. Here's a .west file that got created, and it has just some information about where we tossed stuff, and then we've got NRF, which is basically the first layer of the Zephyr project that got checked out. Not everything is checked out here. If we go under boards, there's only a couple boards here. There's a number of things missing here, and we'll see that fill out in just a sec. So then once you do that, and it even tells you what to do, next West update. This can take a little bit of time, and so while we're talking about that, it'll probably take, I don't know, 45 seconds or so. But what it is doing is it's grabbing basically all of these sub repos, which are effectively sub repos. You can start to see some of those sub repos start to populate on the left side here. We're grabbing a bootloader, grabbing different modules, nrf lib, and we'll go through these in a sec here once it's all done. But basically, we're getting this big tree starting to fill out here on top of the NRF directory, which was initially. So here's what we get. We get, I guess I called my directory nrf, but I've got ncs in the slides. But we get the bootloader directory, which contains MCU boot, which is their bootloader of choice for this this project. We got build, which is, or we don't have build yet, but that is the default location as a root level directory called build, where they put all the build artifacts. You ever want to do a clean build, you just rm rf that just delete that directory entirely recursively, and then you've basically got a clean slate. There's embed TLS, which some folks might be familiar with, which is the TLS library and crypto library. Modules, which basically amounts to third-party libraries, things like the FAT file system, or yeah, just other types of modules like that. NRF and nRF5 lib are basically the driver layers that in nRF5 lib is actually the same wording as in the SDK, so that's familiar to folks who have been using the NRF SDK. And then tests, there's a whole slew of tests. I won't be talking too much about those today, but you can check into them. Tools is basically where they have some dev and testing tools, things like faking out like internet endpoints and things like that. And then Zephyr, which is basically the Zephyr core and the Zephyr project in general. And that's where most of it is. So if you go out and look at the Zephyr, Zephyr proper RTOS, that's pretty much what's in this directory. Just a few places of note in the code layout. You'll notice that there's a boards directory inside of the Zephyr. Yeah, I guess you can't see it from this layout, but there's inside of the Zephyr directory, there's a boards directory. And these are basically all the boards that have made it all the way upstream to the Zephyr proper. And then there's this NRF boards directory, and this is basically the stuff that Nordic has not yet pushed or may never push up to Zephyr. But yeah, you can see how it kind of overlays some different areas for boards there. The other great place to check out is samples. Inside of NCS Zephyr samples, there's a bunch of samples. NRF SDK was great about having lots of samples. Same thing here. There's a bunch of examples. I had to cut it off because there's so many. And then where we're going to be playing for the moment is samples basic, which is a subdirectory there that includes like your typical Blinky. There's a hello world, RGB LED, and then minimal, which is great because that's basically a template for a new app that you want to start. All right, so now we're ready to build an example. One thing that we need to know in order to build an example is we have to provide the board definition. So you can see that in this case, they're specifying, if you're familiar with the Nordic product line, they're specifying a chip, and then they're also specifying a board. So we've got like, you know, the architecture as well as the pinout and stuff all kind of wrapped into one definition. And then you just point it at the, directory that you want to build for your sample app. And you do this the first time, and then after this, these settings stick. Once you have a build directory, those settings will stick. So after that point, you can just do west build over and over again, and it will build those. But the first time, you need to provide those settings. Here's some examples of different build targets if you're familiar with Nrf5 devices that you might be interested in, but you can see it follows a pattern. So let's try it. All right, so here we are sitting in the code. We're all done checking out. Do a west build. Nrf52 PCA 10056, and we're going to build Zephyr samples basic Blinky. We'll just see if we can get things blinking. Of course, no. Target sources for app, which is not built by this project. Include connect load. Aha. Here we go. This is actually the error. Couldn't find boilerplate CMake. That makes me think that I know, it's because of my naming. It is looking for a directory called NCS. So that name NCS is important, and I did not do that correctly. So here we have NRF. It really should be let's see, where do we want it to live? Code NCS. I think we want to move everything into NCS. And if you've ever worked with CMake before, you'll know that you definitely want to just wipe out any cached information in between doing builds like this, moving things around on paths and stuff. Just a tip. Oh, I know there's a faster way to do this, but move tools to NCS, move Zephyr to NCS. Oops. Move tools, move NCSS to NCS/tools. There we go. I think we just got NCS now. Okay. So I'm going to RMRF the build. Let's try this build again. Oh, we got to move the .west file too. That was hidden. All right. There we go. Import elf tools. Aha, yes. So now we have actually hit a missing instruction here. So once we do the West update, there needs to be a pip install Zephyr scripts requirements.txt, and it's -r. All right. So this installs requirements that Zephyr typically needs to build, including that elf tools package that you saw referenced there. There is a second one if you want to build the bootloader. The bootloader has some additional dependencies that aren't installed with the stock Zephyr, and that is pip install -r bootloader scripts requirements.txt. All right, so there we go. Now let's see how we're doing. Can we get a blinky? Yes, there we go. Haha. So now what we've got, let's zip over to Visual Studio Code. So we've now got a build directory, and inside of the build directory, we've got a Zephyr directory, and inside the Zephyr directory, we have a Zephyr.hex and a Zephyr.elf. And I don't know. That's just the Zephyr way. Is it always renames it to Zephyr? So that's how you'll find it. And then there's a bunch of other junk in here that it's generated out of that. And then the fairly cool thing, I guess, about West then is they have integrated it with a number of flashing tools. So I've got a Nordic 52840 dev kit underneath a live video stream on a Nest Cam. I'm going to post that link to the chat. And let's see. How do I do that? Speaker view. Chat. There we go. Okay. So here is the link. You should be able to go to that link and you should be able to see a dev kit that is sitting there looking kind of boring. It's not really doing anything. And it's got about a 6-second delay, so just bear with that. But anyway, what you can do is you can do a West flash. And when we do that, it will flash the device, and it knows how to flash it. And in about 6 seconds, you'll see that one of the LEDs will start blinking at about once a second. There we go. You can see it flashing, and now it's blinking about once a second. So ta-da, we've done Blinky. Let's go look at the code real quick for Blinky. So as I mentioned, we're under Zephyr, samples, basic, Blinky. And then all the projects are pretty much the same, but here's main. There's some device tree stuff that we won't get into, but that's basically how, a lot of dev kits and boards are set to go in this. If you're going on to custom hardware, then you need to understand the device tree stuff. It's a a lot of it is, if you're going with a 52840, you have a pretty clear path. Like a lot of the device tree stuff will remain. It's just really the mappings to the pins. But these types of macros get auto-generated for us during the build process and during the device tree. In Linux, device tree is like this, like in-memory kind of doesn't require recompiling the kernel type of data blob that helps the kernel tell where the different peripherals and devices are. In Zephyr, it's a compile time thing, but it still calls itself device tree because they wanted to be fancy like that and somewhat copy the Linux kernel. But yeah, so we're just finding the LED port, finding the LED, setting our sleep time to a second, and then we run in main in a loop, right? We grab the device port, we configure that as a GPIO output, right to the pin, on and off, basically toggling the pin here with a count, and then K-sleep for a sleep time. So yeah, pretty straightforward. If you wanted to change things, something really easy that people like to do, just do a print K hello world. On this dev kit, we're lucky enough to have a serial port that's exposed over CDC on the USB, so it's very easy for me to pull this up. And then I think just to manage my windows here a little bit, I'm going to pull up the terminal. No, I don't want to actually, because I got to figure out my Python stuff then, my virtual environment. But if I do another West Flash, it'll actually do a rebuild here. Yes, and now it's saying, hey, print K. I don't know what that is, because I put an underscore in it, and it's not supposed to have an underscore. There we go. So now we can go look at the serial port. And, well, probably should have put it in the loop. That would have been more useful. Let's see, but yeah, I think you get the idea. It's a pretty quick, update flash cycle here when you've got all the tools hooked in. Oh, I've got a bunch of different dev kits hooked up right now. I wonder if this is connected to the right one. Well, so actually, this might actually be failing for a reason that brings us to our next slide. So let me jump to that slide. All right, so we already talked about West Flash. This is kind of what it looks like when it runs on the board. Wonderful. So we can, basically we're getting to the point now where we're like, okay, we can get Blinky to work. Now what if we want, and we know how to recompile it if like just minor things in the code change, but what if we want to bring in new modules? What if we want to do some kind of configuration of the device? Well, Zephyr uses menu config. There's also a GUI config that you can run. It's very similar to configuring the Linux kernel, where you just turn things on and off, except in this case, it's almost all runtime. So let's do that real quick. West config, West build T menu config. And then you get a curses menu config, which is kind of crazy and fancy. And they have a bunch of different options in here. Some of the options are, Zephyr already supports a large number of CPUs, so some of the options are not appropriate for what we're on, but some of them are. You can see that our board selection's been chosen here for us. Board options, you can just kind of go through these options with your keyboard pretty easily. And then the other thing that the other way to look through this is like you'll see in the code, you'll see, like let's go into the GPIO driver. We'll see, let's see, is there any config? Yeah, these aren't the right ones though. So if you look for like config bootloader, or basically there's a set of defines all over the system that you'll find that start with config underscore. And they, you know, we'll find it in CMake lists. We'll find it in code, if-def config bootloader kexec, whatever. You know, like there's if config execute in place, bunch of these different things that kind of basically conditionally compile things in and out. And then these work in concert with config files that sit that kind of like set up application configuration defaults. So this is an example of a conf file that's sitting inside of the one of the applications that you can build. And these are basically all of the module choices, yes, no, names, whatever, that are used to configure this. So there's like a lot of, this is basically the equivalent of SDK config inside of the Nrf5 Sdk. And one of the nice things I've found is sometimes you'll be in code and you'll say like, well, I don't know where in the world in this menu config USB NRFX is, but I know I want it turned on. You can hit / and then you just get like a search, and you can do USB NRFX, and boom, like I don't care where it is, but now I know where it is, and now I know how to turn it on. Now in this case, things are showing red, so that means like some prerequisite is not enabled, and so sometimes you do have to kind of, you know, figure out where you are and what you want to do. But in this case, I think what we want to do is enable the console system, so subsystem support. And we don't need to have a get function selection. We just want console. And I think that's the console we want. Console drivers, CDC. Let me make sure. DC mode is something different. Yeah, CDC ACM. But that would be, and that actually this driver is for the Nordic, the 840's built-in USB. We just want console serial. So I think that's the one. Serialized driver. All right. So then we can, it'll ask us if we want to save the configuration when we change it. Yes, we do. We'll do a West build. And West flash. And now we'll jump over to our serial, which yes, now is working. Oops. So now we're getting hello world out every time. So that kind of demonstrates, I guess, you know, how you can have things that compile, but if the modules aren't enabled, things might not work how you're expecting. So thing to look out for. All right, so yeah, so I think some other interesting things to enable. There's a bootloader on here, and I think that one's kind of interesting to enable. Again, you enable that basically just through the menu config, which is pretty nice. There's a Bootloader Mcu Boot, and there it is, it's unchecked. I'll just check it. Save configuration, yes. Do a West build. Now this will actually take quite a bit, well, it takes about 10 seconds longer, and it's building several additional hex files and stuff, because there's actually 2 separate hex files in the bootloader. And then it builds a merged hex file too. Oh, look at that. And what we've forgotten here now is the other step that I added up here, which is to install the requirements for building the bootloader. So this pip install, and I know this because I've run into it before. It's having trouble finding a cryptography module that it needs to build the bootloader. So we will just do a pip install our bootloader script. It might be Zephyr bootloader MCU boot scripts requirements. There we go. All right. Let me update that too. There we go. So now we've got that ready. Now we'll be able to do the get the build complete. And now we've got, you'll see it's also generated a Zephyr Merged Hex. That's the one where it's got the bootloader and the app all built into one. Magically, West Flash knows the right thing to do and will flash the entire thing. You see there's quite a bit more data that we flashed that time. And now when we go look at this, we can actually see the bootloader is running first and then jumping to the first image slot. And now we're running our Hello World app. So pretty quick and easy to get it running on a bootloader too. The bootloader supports BLE updates. I'm not going to demo that today. Also supports serial port updates. So it has some good transports. Let's see, we talked about enabling the bootloader, merged hex. So now, just wanted to show real quick what it looks like to do this development inside of Segger, and specifically, as I mentioned, the Nordic version of Segger. Pop that open real quick. Here we are. So it's a little funky, I'll say. So every time I open it, at least on my Mac, I get this. And I just say no to all. I don't know why it does that. And you know, I think they're working on this actively to make this environment better. But you'll know that you have the right version if it says Nordic Edition at the top here. You'll also see a few extra. It's almost the same as regular Nordic, except it has Open NRF Connect SDK project here. And then under Tools, there's, or I'm sorry, where is it? Project, there's a couple extra here. Yeah, so so when you open this, you get a wizard here. And it basically wants to know, where's the CMake lists file that you want me to point at? And in this case, this is the CMake list file of our application. So you see how I'm diving way into samples, basic Blinky CMake lists. So every app has a CMake list at kind of its root level. And so we're gonna build the Blinky app again. Then it wants the board directory. And this is, you just give it kind of the base level directory. So NCS Zephyr boards ARM. You give it the board name. And it basically, this auto-populates when you complete the board directory. And in this case, most of the boards only have a single board, but there are cases where there are variants that you can choose between. And then where do you want it to put the build? In this case, I'm going to tell it to clean that build directory too, so that we don't have any issues with kind of switching tools here, switching tool chains. There's one step to, I want to make this fail so that people see what it looks like when it fails too, because it's not really super intuitive when it fails, what exactly it means. Oh, look, it did it for us. So this is kind of what it says when, like, basically this wizard is trying to generate an EM project file, which Segger is more familiar with than anything else. And this is the junk you get out when it failed. It just basically says the solution load command failed. Well, that just means that it wasn't able to generate a project that's Segger out of the CMake list, because they're trying to kind of mash CMake into Segger here. So then we can dive through a little bit of debugging here. Let's see, CMake was unable to find a build program corresponding to Ninja. CMake make program is not set. You probably need to select a different build tool. So this is our problem. I'll show you what I missed here, and this is good because other people will have to hit this too. So under Tools Options, there are a couple additional options, and these options used to be on that wizard, but now they're buried here. So this is, these are the pieces that you need to make sure you've got in the right place. These directories need to be set correctly. So one of these is the tool chain directory. So you need to make sure that's pointing to your GCC ARM. These are basically equivalent to those exports that we set in our, initially when we started. And then this has got to be set to your Zephyr directory. And I think, is that pretty much where I'm at? Talk Zephyr, code, NCS, Zephyr, right? Yep. So those look correct. Okay, so why is it having trouble finding Ninja? let's try doing a clean build. Or actually, we at this point we don't even have a project open yet, so we've got to go back to the SDK project wizard, which is popping up on my other screen here. I'll tell it to clean again. We'll see if we get lucky this time. This definitely is a little bit of the frustrating part of working with Segur, but Segur, once it's working, Segur does do nice debugging. Yeah, it's having trouble finding CMake program is not set. You probably need to select a different build tool. I'm gonna, you know what I'm gonna do is I'm just gonna wipe out the build directory here, just to make sure we're not getting anything residual. And then let's try it one more time. Yeah. Even though, despite me clicking the button that says clean build directory, I had to wipe out the build directory and then it works. So there's definitely some wonkiness here. Here's the Zephyr ELF that we built. In this case, it's reset us back to, you know what it was? It has to do with the bootloader. I have not been able to get the bootloader, a bootloader combined project to build, to load into Segur Studio. That's what it was. I remember running into that before. So because we wiped out the build directory, it wiped out our our new menu config that had enabled the bootloader, and so now we're back to just a Blinky app without a bootloader, and now it loaded. But yeah, I mean it's a little funny because like up here is where your app is, main.c. You wouldn't necessarily think to find it under here because it's not called Blinky, and there's no like tree of like samples / basic / Blinky, but that's where it is. Bunch of other projects end up here, and then this is where your ELF file is. You've got to make sure that this is the main file. Like in Segur, when you double click on a project, it goes bold, and then that's kind of like the the project that it will attempt to debug. And so in this case, despite main is an input to our build, but we want to be debugging and loading the ELF file. All right, so once you've got to this point, I'll just show you too, if we did want to configure something, like let's say we want to turn the console back on. This is where, under project, configure NRF Connect SDK project, this is basically where the menu config ends up, but they have a fancy GUI for it. There is still a filter for this, so you can search for console, and console drivers, I guess in this case, is turned on right now, so we should be good to go. It's a little confusing. Load, save as, configure, cancel. Configure means save. Load means reload in case you made it, pulled it off the, made a change outside of the Segur tool. Save as allows you to save it as a separate config. But yeah, and you can check some boxes to, if you want to feel fancy. But all right, so we'll just configure that. We'll do a build here. Otherwise, then this experience becomes pretty largely the same. If you run into weird build issues here, the most common thing I think is you have to have West installed globally here. You can't have it installed in a Python environment, at least on Mac where I'm building. And so this is another weird thing. So I have noticed it says build failed, but it's basically it has finished. It has finished, and either there's something weird in the post link command that's failing, or it's but that it must be innocuous because it doesn't matter. Despite it saying build failed, it is actually successful at this point, and we have an ELF file that we can debug. So we can go here, and if you watch on the screen, we've just reprogrammed the device. Oh no, we haven't. Here we go. Now we're running and loading. Now the device, is loading about 6 seconds later than I'm doing it, and we can pause, and we end up in some, basically we can step through it however we want. So you've got all the tools that you want. There's idle, you know, step out of idle, can run again. We're blinking again, so you can set breakpoints, kind of do whatever. I think we should see too that, yeah, hello world's working again, so. Yep. So I guess with that, any questions? No. That was the main topics I wanted to cover. I'll just zip back to the, yeah, Seger Studio debugging, we talked about it, menu config in Seger, yeah, and then Q&A. So future topics that we'll host for topics in Zephyr, or even just in Nordic related, be automated builds, firmware over the air. They have a new FOTA system in Zephyr compared to the SDK5, Nrf5 Sdk that they had. Nrf9160 and their 5340 are the multi-core devices that they've now have out and really take more advantage of this architecture. 9160 is a cellular device. It doesn't have BLE actually, only cellular, but has some pretty beefy processors. And then 5340 also beefs up the processors. I think it's a pair of M33s, so also a more beefier processor, but does support BLE. And then just diagnosing BLE, since a lot of these Nrf5 devices are being used for BLE applications. All right, with that, thanks so much for joining us. Appreciate it. And goodbye, everyone.